Welcome back to the deep dive. Today, we are strapping in for what might be the single riskiest bet in the modern auto industry.
It's a huge one.
We're talking about an automaker pouring just mountains of cash into developing its own proprietary silicon. I mean, this is stuff usually reserved for, the Intels or NVIDIAs of the world.
And this is a story all about control and a very long-term vision. Our sources here give us a really full-spectrum look at NIO's decision to develop their own chip.
Their self-engineered 5-nanometer ADS chip.
Exactly. The Shenji NX9031. We've pulled from executive announcements by Leavitt Ben, really granular technical specs, and some fascinating analysis of their commercial strategy.
So our mission for you is to really get the why and the how. Why would a car company take on this incredible financial burden?
And how did they even pull it off? Especially when, as we'll see, the whole project almost went under.
And crucially, how are they planning to flip this thing from just a massive cost center into a whole new revenue stream?
And that's really the aha moment right there, the sheer ambition. The R&D investment for this one chip was, according to the company, comparable to the cost of building 1,000 battery swap stations.
1,000. That is not a line item in a budget. That's a foundational business decision.
It is. They weren't just building a faster computer. They were trying to build a competitive moat.
Okay, so let's unpack that. 1,000 swap stations worth of investment. Why? Why not just buy chips off the shelf from NVIDIA, the proven path?
Well, it all goes back to a foundational belief they have about the product itself. They see a car as a 10-year product.
A decade.
For a decade.
Yeah.
And if you want to guarantee the intelligence, the ADS experience over that entire life cycle, you need just an extremely high level of future-proof computing power.
And you can't rely on third parties to give you that guarantee.
You can't. And, this wasn't some random leap for them. NIO has a history here. Our sources point out they were the first globally to launch with Mobileye's IQ4.
That was back in 2018.
And then again with NVIDIA's Orin X in 2022. And what's interesting is they were often beating the chipmaker's own mass production timeline by 6 months or more.
So they were already pushing the limits of the supply chain.
Constantly. And I think they realized that relying on others just meant always waiting, always having to compromise. So for this chip, the NX9031, when they started in 2021, they set three very specific decade-spanning goals.
Okay, so what were the core requirements for this architecture?
First, just sufficient compute and bandwidth. The chip had to be able to support 10 years of continuous software and algorithm upgrades. They were designing for 2031, not just 2024.
That is true long-term thinking right there.
Second, safety and reliability.
Yeah.
I mean, this is automotive grade, so it has to work in extreme conditions.
Hot, cold, vibrating.
Everything. And support ultra-low latency for fused safety systems. This isn't just about convenience features. It's about life-saving response times.
And the third goal. It seems to address the real world. A chip can be fast, but can it see clearly in a blizzard?
Exactly. The third was image processing. They demanded an all-weather, all-scenario image signal processor, or ISP. The ISP is the other part of the brain that cleans up the raw camera data before the AI even sees it. If it can't handle glaring sun or heavy rain, the whole system just fails.
So that sets the stage for the specs. We get the philosophy. But let's get into the nuts and bolts. What makes this chip a credible leader for the next decade?
Well, you have to start with the process node. This is the global first 5-nanometer car-grade process for an ADAS chip.
Okay, so you hear 5 nanometer and you think, my phone has that. But that's not really the right comparison, is it?
Not at all. A phone chip runs in short bursts in your pocket for maybe 3 years. An auto chip has to run constantly for a decade in a box that goes from, minus 40 to over 100 degrees Celsius.
That thermal challenge alone is just immense.
It's a huge achievement in automotive physics, really. And the scale.
The scale is wild. We're talking over 500 billion transistors, a 32-core, big, little E architecture, and it uses LPDDR5X memory running at, 8,533 megabits per second.
Which is incredibly fast. That memory speed is critical, High compute needs massive bandwidth to feed it data. But let's connect that to the headline number.
Big comparison.
The big one. A single Shenji NX9031 chip has the performance equivalent to 4 of NVIDIA's Orin X chips.
Okay, wait, hold on. 4 times the performance. That sounds a little like marketing spin. How do we know that actually translates to a better, safer driving experience?
That's a fair question. It's less about 4 times the raw, benchmark score, and more about 4 times the efficiency in a single package. So instead of 4 separate, hot, power-hungry boxes, they've condensed it all into one. It simplifies everything: cooling, power draw, complexity. And that efficiency directly feeds into the constant updates for their software stack, the NIO world model.
And what about that ISP, the image processor? What's the standout number there?
It has a 6.5 gigapixel per second processing capability.
Translate that for us.
It means the car can process a high-speed, high-contrast scene instantly. So driving out of a tunnel into blinding sun, the system can clean up that image and still identify a pedestrian with basically no latency.
So the proof is in the pudding.
No.
What are the results they're seeing now in mass production in cars like the new ES6 and the flagship ET9?
The outcomes really validate the whole effort. Our sources say it provides the best image effect among current EDS chips.
So goal number 3, check.
It's achieved the highest level of functional safety.
Goal number 2, check.
And critically, it has the most outstanding power consumption level among all high-compute ADS chips. That 5mm efficiency really paid off. They basically hit every single target they set for themselves.
And this is where the story gets really interesting, because we go from the technical side to the sheer grit and financial risk. Because at first, no one thought this would work.
Oh, absolutely not. The industry view is that a car company trying to make its own chips was too big a leap, a financial black hole.
Because the R&D cycle is just so long.
And if you fail, all that money, those billions, are just gone, wasted cost.
And they didn't take the easy route. We know the investment was massive, but they also avoided that lighter weight spec-in, spec-out model.
Right, where you basically just outsource the hard stuff.
Yeah.
Instead, they committed to developing the core technologies, the MPU, the ISP, the whole system-on-chip architecture themselves, in-house.
That requires a totally different mindset.
It does. They talked about it with a specific Chinese phrase, "Hai-fi-yu-pen-a."
Yeah, what's the translation on that?
It's something like, a soldier advances one step per day, and success comes over time. It's about doing the hard foundational work yourself, patiently, even if you don't see results for years.
And that patience was tested big time in 2023. This is the crisis moment that nearly sank the whole thing.
It really is. Just as the chip's front-end design was almost done, a key partner just abruptly announced it was ending its operations in China.
And the whole industry thought.
The project was doomed. The consensus was the delay would be catastrophic if they could even recover at all.
That is just incredible pressure on the leadership team. Imagine having to make that phone call.
But they turned a potential fatal blow into an advantage. Instead of scrambling for a new supplier, which would have meant huge delays, the team just rapidly built those capabilities themselves, in-house.
Wow.
They filled the gap, overcame the hurdle, and actually advanced the overall schedule by at least 4 months.
That really shows the difference between being a customer and having a core competency.
It does. And the ultimate validation came right after. The chip achieved a successful first tape-out, meaning it worked perfectly the very first time they manufactured it, which is rare for a chip this complex.
Yep.
And now it's the world's first 5mm high-level ADAS chip in mass production, in cars on the road. The gamble paid off.
Okay, so they've climbed the mountain. Now let's talk about the business.
Yep.
How do you get a return on an investment that massive?
Right, the monetization. So the first most immediate benefit is internal. The chip is projected to bring about a cost optimization of around 10,000 RMB per vehicle.
Which is roughly $1,400 US.
Exactly.
But wait, if they spent, let's say, over $1 billion and they're saving $1,400 per car, I mean, you have to sell a lot of cars to make that math work. Isn't it still just a huge sunk cost for now?
It is, if you only look at the internal savings. That $1,400 isn't just a saving, though. It's also a competitive weapon. It defends their gross margin in a price war, and it pressures every competitor still buying chips from a third party. But the real game changer is the external plan.
The plan to turn this into a new revenue stream, which they announced earlier this year, they're opening it up.
Exactly. This is the move that shifts NIO from just a car company to sort of a technology platform. They're going to license the IP. They've already signed a deal with one other automotive chip company.
So what does that look like? Is it like you can license just one piece of it or the whole thing?
It's both.
Yeah.
And that's where the value capture gets interesting. You could license a single piece of IP, like maybe just their advanced ISP technology. That's typically a deal in the several million USD range. But if you license the system-level sauce, the whole architectural blueprint, that could be a deal in the hundreds of millions of RMB level. They can monetize at every layer of the supply chain.
And they had to create a whole new corporate structure to manage this, right?
Yes, they established Shenji Technology Company to handle the R&D, production, and the licensing business. And they've already formed a joint venture with another semiconductor company, showing they're serious about partnering and scaling this.
So this chip, the NX9031, it's really a critical value realization point for them. They're moving out of that heavy investment phase and into what they're calling a harvest period.
Absolutely. And the tight integration of their own chip with their own software, the world model, is the real moat. It eliminates all those messy hardware-software integration problems that plague other companies. It strengthens their position for the next decade.
And when you look at the bigger picture, this moves them away from just competing on price, that sort of low-quality internal competition we see everywhere, and towards real technical leadership on a global scale.
That's the core belief here. That self-developed technology is how you build a real moat, how you differentiate on quality and innovation, not just cost-cutting.
So this deep dive has really shown the incredible difficulty of this kind of vertical integration, from the pure physics of a 5 nanometer auto chip to surviving that 2023 supplier crisis. It's clear that high-end computing is now one of the new three core components of an intelligent EV.
And that raises, I think, a final important question for you, the listener, to think about. Given this monumental effort, the billions of dollars and years it took them to get here, how much harder is it going to be for any automaker that hasn't made this commitment to catch up over the next 5 years? That gap, both technologically and financially, it seems like it's only going to get wider.